Okay, in this video we're going to talk about how to find the inverse of a function. An inverse function simply reverses another function by switching its input x and its output y. So really, all it does is it takes an x and y and just switches them. Okay, we're going to take a look at what that means both graphically and algebraically. So first we're going to focus on the graphical interpretation of what this means. Okay, so let's take a look at this relation where we have a set of values x, and then we have a set of values y, and then let's go ahead and just graph this first. Okay, so we have 0, 2, so 0, 2, I'm going to graph all these. 4, 1, sorry, that's 1, 4, 2, 5, 4, 6, and then 8, 7. That's going to be up 1, 2, 3, 4, 5, 6, 7. Looks like it's right there. So I can graph these, or if I can connect these, just to kind of visualize what the shape of this is going to be. All right, and we can do the same thing now with the inverse relation. However, the inverse relation, if we know that the inverse just simply switches the x and the y's, then let's go ahead and make our y values, let's go ahead and switch them now. So instead of our x's, we're going to make our x's the y's. So you're just kind of flipping them, okay? So I'm going to write these values right here. Okay, let's do it. So instead of 0, 2, we have 2, 0. Instead of 1, 4, we have 4, 1. 2, 5, we have 5, 2. 4, 6 becomes 6, 4. And 8, 7 becomes 7, 8. Okay, so that is going to be our inverse relation, okay, our inverse function. Now let's go ahead and take a look at what this is going to look like graphically. It's going to be really interesting. Okay, so instead of 0, 2, we're going to graph 2, 0. So it's going to be 2, 0 right there. Then we go to 4, 1, 5, 2, 6, 4, and then 7, 8. Right here. Okay. You'll see they kind of look similar, right? They kind of look pretty similar, right? So what happens, or what we can visualize here, is when we switch the x and the y, what that really means is we are letting y equal x, okay? So when we look at this graphically, when we graph the line y equals x, it is just that line right here. Okay, it's that kind of 45-degree line that goes down, kind of splits that graph in half. And what you'll see is that blue graph, the original relation, just reflects and creates the red graph, that inverse relation. So if we look at this as a definition, the inverse function f negative 1, that's just the inverse of f, is a reflection of f across the line y equals x. Okay, so that is what we do when we graph it. You just take the line y equals x and you switch the ordered pairs. So that reflects over the line y equals x. So that's what it means graphically. Here's what we're going to do now algebraically. So the same concept still applies. We're just going to switch the input x and the output y. So we're given just some basic function of x, 2x plus 4. Okay, so here's the strategy that we do. We're going to replace f of x with y. So instead of this f of x, we're just going to write y equals 2x plus 4. Okay, just so it's a little bit easier to understand. When we have f of x versus y, y looks a little bit nicer. Okay, switch x and y in the equation. So remember, we're just switching x and y in the equation. That's all an inverse does. Okay, we have x equals 2y plus 4 now. Okay, so all we do is switch it. And now we are using inverse operations, right? Inverse operations. That's why it's called the inverse function. Okay, so in order to use inverse operations to solve for y, let's go ahead and solve this. So we're going to subtract 4. All right, just think back to your first algebra class. So we're going to subtract 4, and we have x minus 4 equals 2y. Okay, so that's going to be divided by 2, and what that's going to simplify to x over 2, or 1/2 x, minus 4 over 2. 4 over 2 is just 2, so that equals y. Okay, so we can kind of simplify this even more, and we can just write y equals 1/2 x minus 2. And so this now is the inverse function, where we just write, instead of y now, we're going to write f negative 1. That just means the inverse function. So we're going to write f negative 1, or f inverse of x, equals 1/2 x minus 2. Okay, so now that's algebraically how you find an inverse. What we can do with that information is, let's say we take our original function, so our original function f of x equals 2x plus 4, and let's just plug in a value. Let's plug in like a value of 3. Okay, we're going to plug in a value of 3. So f of 3 equals 2, and since x is 3, we're going to plug in right there. Okay, so there you go, plus 4. So now from here we can say 2 times 3 is 6 plus 4. So f of 3, function of 3, equals 10. So that means if we plug in a 3, we're going to get a 10 out of it. So now let's see what happens if we plug in our inverse, or we plug in this 10 to our inverse function. So let's see here. So let's use our inverse function. X minus 2. Okay, and now we're going to plug in our output. Okay, so we're going to see what happens when we plug in our output. So let's do that. We have f inverse of, now we're going to plug in our output. 10 equals 1/2 10 minus 2. Okay, so let's go ahead and see here. Well, 1/2 of 10 is 5 minus 2. 5 minus 2, so f inverse of 10 is equal to 5 minus 2 is 3. Well, that was our original input, so that is a good way to verify and check to see if your inverse function is correct. Okay, so knowing this, we now know that this is in fact a correct inverse function of our original function. Okay, so now let's tie this all together with a graph. All right, so we have our inverse function, and we have our, we have our original function in red and our inverse function in blue. And we're just going to graph this real quick. So I'm going to go up 4, and then I'm going to do a slope of 2. So 2 over 1. I'm going to go in both directions. Okay, that should be fine. And I'm just going to sloppily draw a line here. That's not bad. Okay, so that's my line of the original function. Now let's take a look at our inverse function in blue. So we're going to go down 2 of our y-intercept. So our y-intercept is down here. And then a slope of 1 over 2. So in this case, it's kind of flattened out a little bit. Up 1 over 2, up 1 over 2. Keep going. Okay, and I can go the other way. Actually, it's going to be really important to see if we go the other way what happens. Okay, let's draw this line. All right, I'm going to continue this red line a little bit further. There we go. All right, so let's make some observations here. Okay, so we notice that the graphs intersect at the point -4, -4. All right, that's this point right here. So we notice that because, well, -4 and -4 are the same, right? Well, if you switch the x and the y values, well, -4 switching with -4, that doesn't actually change anything. So that makes sense as to why they would intersect at that point, right? Whenever that value, the x value, is the same as the y value. So that's always going to happen here. All right, another thing, let's observe a random point on the red graph. So let's just choose a point, I don't know, right here. So let's make this, it's going to be -1, 2. So let's just observe what happens here, -1, 2. And what happens if we maybe switch -1 and 2, so -1 and 2, if we switch it to 2, -1. Well, let's see where 2, -1 is. So we go right 2 and down 1. We'll look at that. So that is no coincidence, right? That's no coincidence because we know that should be on the blue graph. It's no coincidence because an inverse simply just tells you that you are switching x and y. Okay, so if we switch x and y, negative 1, 2 becomes 2, negative 1, and you do that with every single ordered pair along that red line, then you're going to have this new blue line right here. And so what you can notice as well is if you draw that line down the middle that we talked about earlier, like this, okay, that's going to be our reflection right there. Okay, you can see that these two red and blue lines, they just reflect over that axis. Okay, so there you go. Those are some observations about the graph and the algebra behind it. All right, so just a quick summary. To find an inverse function of f, all you have to do is switch x and y, and then you're going to solve for y. And we've talked about kind of the background behind why that works and what it looks like graphically. So I hope that helps you out a little bit. And that is inverse functions.